WABYA here. Going to give you a real quick look at the version 2 of the 10 gig dish assembly. This is going to be tower mounted. The reason I'm making the video is to help out others who are attempting to do a tower mounted dish for the first time. There's not a lot of information on the internet on how to do the mechanical work or many designs for that. There's a lot more information about the electrical aspects. So a lot of this was trial and error and design as I go. First of all, the dish is straight off of eBay. We picked it up for about 22 bucks, and shipping was about the same amount. Came from Ohio. It's 26 inches vertically by about 24 inches across. And what we did is we took off the original LNB and we bought some U-channel aluminum, and we cut some slots in it here, and we made a pivot mount for the mount. This particular mount is a single band 10 gig feed from Italy, I0JXX I believe. Very good quality mount, excellent return loss. And the way I've got it set up is the mount is allowed to slide forwards and backwards on the original arm that comes out that holds the LNB, and we've got some slots cut in, some screws. That'll allow me to fine tune the position of the feed, and we've also made it so that the feed can be elevated up and down. We've got a small pivot in here. This is going to be replaced with a stainless steel rod here. And then we'll have a pair of aluminum strips coming down. And what I'll do is I'll fine tweak the angle. And then once we find it, we'll use some stainless steel self-tapping screws to tap that in, so to fix that angle there. So the idea is to provide some flexibility to fine-tune this. The idea is once it's finished, we're going to take it, set it up in the garage, and then point it to the north at a small low-power beacon 10 gig source of RF. And we'll hook up my microwave spectrum analyzer directly to the feed, and we'll be able to monitor the beacon's signal from about 500 feet away, and that'll allow me to tweak the feed's position to optimize it. Once I figure out where that needs to be, we'll go ahead and nail that shut and make it more permanent. So moving on here, this was the most critical part for me. This is the hardest part, and fortunately I had some help from my friend Peter and Hugh up in Kanukistan. And what I did is originally I had purchased some pillow blocks bearings and had them mounted to this 1/2 inch aluminum plate, and we're using 2-inch aluminum kind of as the bearing. The problem is those pillow block bearings were awfully heavy. I thought I was purchasing aluminum zinc alloy bearings. Turns out they were cast iron, and they were horribly heavy. So they ended up weighing about 20 pounds for the pair of them, and I thought that was just a little bit too ridiculous. So for about a week I struggled with how to replace them. And then I just decided, you know, why don't I make my own? So all of these U-bolts, all the hardware is stainless steel. And so what I did is, and these are brazed, by the way, these nuts are brazed on here, so they will not come off. If this needs to be removed, it'll have to be destroyed and then replaced. But what the U-bolt does, comes out to a brass tubing. It's acting as the outer part of the bearing, and I had to turn down ever so slightly this 2-inch OD. This is actually mast material. It's 1/8 inch wall, and it was just a hair too big to fit inside this brass. And so what I did, fortunately I've got a metal lathe, and so I just turned down the outside of this from about here to here. Just took it down about I don't know, about 50 or 60 thousandths, and then it slid in just like a glove. We'll put a little bit of grease directly underneath here, although it's really not necessary, but I'm going to keep the galvanic corrosion down to a minimum, because brass and aluminum do react. So the grease gooped up in between here will minimize that. But the key here is that the U-bolt is brazed to the brass collar, and so that holds it still and allows this to pivot as the dish needs to elevate up and down. So this was the design. This 1/2 inch aluminum plate does not have to be this thick. If I had 1/4 inch available, I would have used it, but even 1/4 inch plate this size runs about $50–60 before shipping, so it's horribly expensive. And since I had 1/2 inch on stock, I went ahead and just used it. This is off an aircraft carrier, part of a blast shield. So that's the key components. What I am going to do is I am going to double up. I'm going to add one more U-bolt up here, and then we're going to add one more down here, so that this entire assembly will actually be held to the mast with 2 U-bolts up here and then 2 down here. But right now it's only showing one on the top and one on the bottom. Over here, this is 4-inch by 4-inch angle, aluminum angle. It's 6061 T6, 651 actually. The reason for, and it's 1/4 inch thickness, using 3/8 inch stainless hardware to bolt these plates to the existing sheet metal work from the dish. This hardware does not have to be 3/8 inch. As a matter of fact, if I had 1/4 inch stainless stuff, I would have used that. That would have been a lot more appropriate. Again, since I had 3/8 hardware available, that's what I used. So a lot of this is really overkill, but it's used because it's what I had. This allows me to make the mechanics necessary to create a pivot, and this is 1/8 inch thick wall. It's rectangular stock, and we've got that bolted in. This is using 1/4 inch hardware, and so that's very, very stiff, and that creates the arm. And then what's nice is I just used a pair of thin, this must be like just a little over 1/16 inch wall aluminum plate here. What's nice is you can fine-tune the position of these plates along this arm to find the sweet spot that you need. I would prefer to use an actuator that had more of a throw, but this was given to me by a friend for free. So again, using what I had here, it only has 6 inches of travel. So what I've done here, for example, right now it's set at its midpoint. 3 inches of the arm has extended out, and with 3 inches of it out, this is mid-travel. What I did is I arranged everything so that the dish is tilting down at about the correct angle. So once it's mounted on the tower, it would be roughly pointing at the horizon. If I'm not mistaken, I think that arm from horizontal needs to be down about 22-23 degrees from what I recall on my first tripod setup. Once this arm is down 22 or 23 degrees, the dish is actually pointing at the horizon. So I set up mid-travel to equate to flat at the horizon. Thus, when the arm is extended further out, I can go below the horizon about 11 degrees, and then I can go up about 11 degrees. Some of you might be wondering why I went to all the trouble to come up with an elevation system for a tower mounted setup. Since this is for terrestrial use, this is not really primarily intended for EME or anything like that. The reason is this, although that's not the tower that's going to be used, I can illustrate the problem here. So this is just one of the towers. This is my VHF tower, and it's 70-foot tower, and there's about 15 feet above the collar. Now, even though I tried to make the tower vertical and the mast vertical, these dishes are quite narrow, as you know. They only have about a 2 or 3 degree beam width. So the problem is if the tower is slightly off, if it's tilted ever slightly off in one direction, or if the mast is slightly crooked, my dish could actually be pointing down, say 2 or 3 or 4 degrees, and I'd be pointing down into the ground, and that would not work. So having the ability to elevate the dish up will allow me to find exactly where horizontal will be and compensate for the tower and the mast not being plumb. I'm sure, and again, this is not the tower that's going to be used. I'm going to be using same type of tower and mast but further north, and the dish will be at 85 feet. So the idea is, again, to be able to compensate for any non-plumbness of the tower or the mast. If I knew for a fact that the dish was going to be perfectly horizontal, then it'd be child's play to mount the dish to the mast, much like the directive systems setup that I've been using for the last year and a half to make all my contacts thus far. So that's real easy to mount. And again, even with this short tower, this is only at 61 feet. I'm positive in some directions I'm pointing down into the ground, and in some places probably pointing too high. So what we've got here is, this is a very cool elevation indicator that I've got mounted on one of the arms. What's cool about this one is that it uses Ethernet cable, and here I've got a short length set up, and if we turn it on, there we go. So what's cool is I can go ahead and I can zero it, and if we assume that this position here is going to represent 0 degrees, then I can go ahead and zero it, and as the dish travels up and down, I'll be able to monitor the elevation of the dish precisely with this here. As a double check, what I did while I'm building this, I just used one of these small, inexpensive magnetic bottom. Let's see if we can get this to turn on. There we go. Alright. So this is showing currently about 22 degrees. Yeah. Just shy of 22 degrees. And again, I'm assuming 22 degrees roughly is where this dish needs to be for it to be pointing at the horizon. If it needs to go down a little bit more, that can easily be adjusted by moving the U-bolt up or down, or I can reposition these brackets here. But I'll show you how it works. Now, another problem that I had is this actuator, even though it's 12 volts, I'll be running it off of 13.8. I've got a temporary power supply set up here. It travels way too fast. This thing just books in and out. So what I've done is I'm using a small DC motor. It's a pulse width modulated speed control. It's a pretty cool setup, and I'll show you how it operates. It has a up and a down button. Off is in the middle. I found the setting here gives me a pretty good rate of travel. So if we see here that we're set at 0 degrees, and we see here is roughly 22 degrees, we can go ahead and move this down. And what's nice is it only draws about 1/8 of an amp. So here now we can see this has gone down almost 11 degrees, and sure enough, this one here matches what we saw there. See if I can get that angle there for you. Yeah, so it's 32 and a half roughly. So showing again about 11 degrees further downward elevation. Going up, there's a little bit more power required. Fortunately, it's still only drawing about 1/4 amp. And I can speed that up or down. I can make it crawl if I wanted to. I think it's pretty cool, actually. I think it turned out pretty good. So once that finishes, we can see here now the elevation angle has hit just shy of 11 degrees, 10.8. So we're now up 11, and here we're seeing exactly the same thing here. We're seeing 10.9, or just shy of 11 degrees. So the two instruments, this temporary one and plus this permanent one that's going to be on there, are in agreement. I wanted to make sure of that. And it's allowing me to right now travel 11 degrees up or 11 degrees down from its nominal, what I can think is, hoping is horizontal. So the only other part that was a little bit tricky for me was building this setup here. So what I did is, again, I wanted to use stuff that I had. So what I found is some 1/4-inch steel stock, and with a oxyacetylene torch I turned that red hot, and I made a nice curve, made a nice bend that comes around. I formed it around the stainless steel 3/8 bolt here, and so that makes a nice tight fit there. Did the same thing around this way. When I was finished and it hardened, I went ahead and ran a drill through to make sure the bolt would fit. Stainless steel hardware again, and I just took a couple of pennies here, drilled a hole through them to act as a washer, and then a couple of stainless steel cotter pins here. So this will not be able to move back and forth here, and yet it provides a very, very robust and completely fluid way for this to pivot up here. Down here, very similar type setup. We're using, this will be cut off here. This is stainless steel hardware, and I'll be replacing this, making this look a little bit nicer, or I may just leave it the way it is. But this same type of idea, using a 1/4-inch stainless steel bolt running through as a pivot, and it's very, very fluid, provides very, very little resistance. And as you can see, this small actuator has no problem running this up and down. The only thing left to do is I'll be greasing underneath here, and then I've got a little bit more of this brass stock here. I've got one this size right here. I'll be cutting it in half, and then I'll be sliding it right on the outside here, and then just running a self-tapping stainless steel screw through this outer collar. What purpose of that will be to push up against this collar, and I'll do the same to the other side on the outside, and that will keep this 2-inch pivot point from being able to shift in any way on my homemade bearing. So I know that maybe I didn't explain it really good, but I could use a hose clamp, for example, right around the outside or the inside. If I put one on the inside here, I'll put one on the inside on that side, and that will keep the 2-inch pivot point from being able to move in any way. Or I could put the hose clamps on the outside here and on the outside there. But I think I'm just going to use take one of these brass collars, cut it in half, and just slip it over. It'll end up right here, and then I'll just drive a screw through it to hold it in place. It'll just kind of like be a cap to ensure that this cannot, this shaft here cannot move one way or the other against my bearing. So that's the setup, and I hope this helps, especially if you're contemplating putting one up. Again, You could use 1/4 inch plate. I think that'd be fine. Here you're still going to need something that's roughly 4" by 4", but rather than 1/4 inch wall, you could probably get by with 3/16. Shave off a little bit of weight and save yourself a little bit of money. But for all the rest of the hardware, I strongly recommend sticking with 3/8 inch U-bolts and hardware. Make sure that it doesn't come down in some heavy winds and icing and things like that. All of these stainless steel hardware, these could be 1/4 inch. I don't think there'd be any problem with that whatsoever, because the weak point here is this dish mounting to their original sheet metal work that goes on the inside here. As you can see, it's only bolted on in 4 places, so in a really hellacious windstorm, whatever, this dish is going to get ripped off, this entire mount right here at these 4 points here. So this whole thing is really overkill for what we've got here, but it's not worth it for me to try to build up any more mounting to the dish here. I just don't see it as being a problem. So that's what it looks like, and this will be in the shack. This will be my elevation control. We'll have the readout. I'll be able to tell exactly what elevation the dish is at, which is really cool. I've tested it with 150 feet of Ethernet cable between them, and it works just fine. Interesting thing about this is this is an older model, and I don't know if you can get this model currently with this long Ethernet connection. The one that I did see shows they have Bluetooth options and things like that, but I think this older model is actually a better one. And even though they specs only say, oh, I don't know, something like 8 or 10 feet of cable, I said, well, let's try it with 150 feet, and it works just fine. So apparently it's DC levels or very, very low frequency signals that are being transferred over that Ethernet cable. So 150 feet does not seem to bother it. So next thing will be to, then after that, we'll be putting the buttons on the electronics. This time we had to change things around. I've modified the DEMI, had to pluck out a resistor to disable the internal oscillator, to force it to use the external oscillator, because there was a problem with the Q5 oscillator board that was inside here. So we went ahead and disabled that. We'll be using external GPS 10 meg reference, and we'll be running this entire operator. There's a 13.8 volt 10 amp power supply, and for the first time we'll be running 110 volts AC up into the Hoffman box. So this ultimately will be the 20 watt PA heatsink for it. In this initial run, the heatsink and the 20 watt amplifier will not be installed inside here right now. I just want to get this up before winter and make sure that it works. And then again, we'll be fine-tuning the feed here, making sure that we've got the position of it correctly so that we're illuminating the dish properly. And then we'll be fine-tweaking the elevation of it. And then once we fine-tune that with the spectrum analyzer and the beacon source, then we'll go ahead and pour epoxy on the whole setup. And this here, by the way, this is my crude way of coming up with the mount. This is a channel material, and then what I did is I wrapped the feed with a very thin layer of saran wrap, and then I potted it with Bondo. I put Bondo inside the channel and then just pressed the feed down into the Bondo until they cured. And so this whole thing can come out very easily, but I've got a perfect 1-to-1 mold, so it's a very nice snug fit. And all we're going to do is put maybe a hose clamp around it here and then one in the back, and that'll secure the feed into the bottom channel here. Alright, so I hope this helps, and like I said, there isn't a lot out there on the internet to show the mechanics on how to pull something like this off. Basically what I've learned is that everybody kind of does it their own way. Everybody kind of reinvents the wheel, and it can be difficult. I'm more of an electrical guy, not a mechanical guy, so for me this was the most challenging part, was coming up with this mechanism, the mechanics of it, not the electronics part. So I'll go ahead and post this, and if you have any questions, just let me know. 73.